A solution is a homogeneous mixture, and it has very tiny particles that don't reflect light, so as a result, they cannot be able to be seen, so they're so tiny. Also, the particles are too small to settle or be filtered out of the mixture, and everything in the solution is evenly spread out and dispersed in the...
And then within a solution, there's two main components, a solute and a solvent. The solute is the substance that is dissolved by the solvent, which is the liquid that dissolves the substance. And the amount of solute that a solvent can dissolve is called the solubility. And then our example is sugar water. And then this is sugar and water, which is this and this. And then you have to mix it up. And right now you can see the particles, but when you mix it up, it eventually turns.
We did molecule, and a molecule is two or more atoms joined together. So this is just an atom, so it's not a molecule because it has to be two or more. So this is an example of a water molecule. And these are the two hydrogen and one oxygen, so H2O.
And this is the glucose molecule. It's what plants eat. It's the sugar plants make.
Heterogeneous mixtures and the definition of a heterogeneous mixture. Well, a heterogeneous mixture consists of dissimilar parts or elements. Examples of heterogeneous mixtures are trail mix, carbonated water, oil and water, and you know how you get candies in a bowl, the mix you get from Halloween sometimes?
Okay, so we had suspension by me and Ryan. Suspension is a heterogeneous mixture with large particles. An example of suspension is muddy water because the particles are large enough you can't see through it. So if I held up my eyes, I can't see anything. That's it.
We did the word emulsion by us. What is an emulsion? An emulsion is a mixture of two liquids that would, under normal circumstances, it would not mix together. How it is.
Okay, so to get a better understanding of an emulsion, it would be two liquids that don't mix together. So you guys know oil and water. Have you ever mixed them together? The oil will go to the top, the water.
Or oil and vinegar.
Yeah, or oil and vinegar. And so oil and vinegar, it's salad dressing, vinaigrette. So this is an example of an emulsion. And some stuff is at the bottom. They don't actually mix together. If you shake them, they mix for a little bit, but they don't stay mixed. And if they stay mixed, it's actually called a permanent emulsion, which is like mayonnaise. And to have a permanent emulsion, you need the two base ingredients, and then you need another ingredient. So yeah, and then ice cream is an emulsion, and milk is an emulsion too, because the water-based stuff.
Alloys. So an alloy is a metal made by combining two or more metallic elements, usually to give strength or resistance to corrosion. So to simplify that, an alloy is basically a mixture of two or more metallic substances or metals. But wait,
there's a catch.
I need this one.
Okay, so besides metals, most of the time, the word alloy, it's described as a mixture of metals, but it's a little misleading because some alloys contain one metal, and it could also be mixed with other substances or nonmetals. For an example, cast iron is an alloy. It's made of just one metal, which is iron, but when it's mixed with a nonmetal, which is carbon, it's still an alloy. The best way to think of an alloy is a material that's made up of at least two different chemical elements, of only one of which is a metal. And the most important metallic component of an alloy is called the main metal, the parent metal, or the base metal. And the other components of an alloy, which are called the alloying agents, can be either metals or nonmetals, and they're present in much smaller quantities, sometimes even less than 1%.
Something that cannot be broken down into more simpler substances chemically, everything
ever is made of elements. So, say there are compounds and mixtures and so on and so forth, but their component parts are all elements. And there are 118 elements discovered thus far. 92 of those are naturally occurring, and 20 of them are man-made. And the way that the elements are differentiated from each other is they have different physical properties, like you're able to tell them apart, physical and chemical properties. But the thing is that really determines the elements is like the number of protons they have in their nucleus.
There's antimony, arsenic, aluminum,
Alright,
selenium,
so
hydrogen,
while that's
oxygen,
playing,
nitrogen,
I will
ruthenium,
explain.
nickel, neodymium, neptunium,
The periodic
germanium,
table of
iron,
elements, here it
americium,
is
ruthenium, uranium,
divided
rhodium,
into
plutonium,
different,
lutetium, vanadium, and lanthanum,
different groups.
lanthanum, and radium,
So this group here, the orange ones,
indium, and gallium,
these are the
and
alkali,
iodine,
the alkalis.
thulium, and
And the
thallium.
thing, each group has something distinctive about it, like
There's
how
yttrium,
each of
ytterbium,
the
actinium, rubidium,
elements is
boron,
distinct to each of the
gadolinium,
groups is
niobium,
too.
iridium,
So
strontium,
the
silicon,
alkalis,
barium,
when you put them
lithium, beryllium,
with
and
water,
thorium.
they explode. Like, big explosion.
We're doing compounds, and a compound is a two elements that combine to form a different mixture or like a different substance, which has different properties than the original two substances. And some examples are salt, which is made of sodium and chloride, water, which is made of hydrogen and oxygen.
Is it liquidy or powdery?
It looks solid. No, it looks liquid.
Liquid, yeah. Any other evidence of a chemical change occurring?
There's like a gas forming. There's
Certainly a
there's
gas.
condensation forming.
A little bit of condensation.
And a mixture is a combination of two or more substances in any proportion. The substances don't combine chemically to form a new substance as they do in a compound, and they keep their original properties, they just intermix. And a mixture is pretty much just something that can be physically put together and also physically taken apart. And a component of a mixture is they keep their identity when they combine, unlike other things, but they usually can be easily separated again, and their different physical properties are used to separate them.
This is a mixture because it's things combined. A colloid is a homogeneous mixture, and the particles are of medium size, so they're not very large, but at the same time they're not very small. They're large enough so that you can see the particles, but they're not that small. Like, at the same time, they don't filter out. Like, homogenized milk is a colloid, because non-homogenized milk, there's cream at the top, and then there's the actual milk, so all the layers separate out. So it becomes a suspension. But like homogenized milk, it's like all the particles are in the same layer since it's a colloid. And then one of the things about colloids is the Tyndall effect. And that's normally when you shine, if you have like a test tube filled with water. A colloid, like milk, then you can see where the test tube is. The light is not showing. It's because the particles are much larger or a little larger than the ones in water, so they're scattering the light. And also sometimes, I don't know if you can see in the room right now, is when the projector is on and then the lights are off, you can sometimes see like the particles in the air. And
This
then
is our atom project.
An atom is a fundamental unit of matter. All mass in the universe is made of atoms. All matter is made up of atoms, so they can be found anywhere matter is present. They remain physically unchanged regardless of matter's state.
So even if matter is in a solid form or liquid form or a gas form, as this picture shows, it'll still be made of the same atoms. It's not like the atoms are going to just suddenly change or disappear. Protons and electrons, which I'm sure you all know. The nucleus of an atom is composed of protons, which are positively charged, and neutrons, which are neutrally charged. And shells outside of the nucleus, electrons orbit. And in a normal atom, the number of protons and neutrons are equal. So in a normal atom, it would be neutral, called quarks and gluons. So protons are positive, so they have two up quarks and one down quark. And neutrons have one up quark and two down quarks. And gluons, they sound like glue and they act like glue. So they kind of glue the quarks together to help form the atom. Or the particle that makes up the atom.
This is the crystal.
What is a crystal? Crystal is a homogeneous structure having a natural geometric figure. Crystals are created by an ionic bond where every positive ion has a negative neighbor. The atoms within the crystal use these atomic bonds to create a three-dimensional figure. They are a three-dimensional arrangement of atoms within a solid.
Okay, well, there's many like shapes of crystals. There's more than these, but these are like the basic ones. Cubic is like a general crystal shape, which like this one where it forms in a cube lattice. Triclinic is like an odd shape, kind of like that geode. And it has an amethyst growing in there.
Whoa.
Okay. And monoclinic is just a general rhombus, strongest crystal like diamonds and zinc. Like they're the hardest type of crystal because they bond really well with each other. Metallic crystals are crystals that are like in metals such as mercury and iron. And ionic crystals are crystals that are bonded by when an electron meets with another atom, where they could really use the electron and they connect to each other, making that bond. And a molecular crystal are when the molecules of each of the crystals combine with each other, and they work out, and they end up making a crystal like iodine and phosphorus. Yeah.
Crystals are used in many things other than being found and studied. Crystals are used for medicine and for healing in hospitals. Computer chips and programmers both use crystals for storage of data. Clearing also uses crystals in the soaps created, since crystals can also contain cleaning properties. Even our food contains crystals in our salt and sugar. Proteins in our body use crystals to determine their structure.